Yes, hello, good day everyone. Good day, Miss Mendoza. My name is Conducto and I am from grade 11, St. Teresa of Avila. I am here today to discuss the problem given to us prior to our video computation. And here's the problem, and unfortunately, after this short clip, my footage got blurred, so I will have to fast forward. And here it is, I'm going to read the problem. A compound contains 10.13% carbon and 89.87% chlorine. Determine both empirical and molecular formula at the compound given that the molecular mass is 237 grams per mole. Now that my footage is back, I will discuss what I usually do when I have word problems. So this is the first one. I always put all the variables, which is the carbon, the chlorine, and the grams per mole. I was not able to specify in my paper the steps of calculating my empirical formula, so I will just voice over it instead. So step 1 is to assume 100 grams of sample. I didn't indicate it in my paper because I thought it was a no-brainer. So the second step is to convert grams into moles, and this is the formula. The formula is to use the given number, convert it to grams, and to multiply it by 1 over the atomic weight. The first problem that I solve is the molar mass of carbon. The formula is 10.13 grams over 1 mole over 12.011, which is the atomic weight, which equates to 0.843. And lastly, I solve for the molar mass of chlorine, and the formula is 89.87 grams multiplied by 1 mole over 35.453. And this equates to 2.53. And now you guys might be asking, Theron, what do we do now? And luckily, I am obliged to answer your question. We will proceed to step 3. We will divide the biggest mole by the smallest mole. And if you're like me, why not divide the smallest mole by itself to get the number 1? And here's the following answer that we have. By dividing the biggest mole by the smallest mole, we have 3.001. And here's what I'm talking about. I divided the smallest mole by the smallest mole to get the answer 1, which is so hard to get nowadays. And just in case we all forgot, we got the biggest mole from chlorine, which is 2.53. Therefore, we will use 3 to the chlorine in order to make our empirical formula. Here is our final answer for our empirical formula, CCl3. Here we go. And here I was to write the words empirical formula using a red ball pen, but unfortunately, the red pen has run out of ink. So I rage quit, and then we're going to use the black pen instead. So we will write EMPERICALFORMULA for empirical formula. There we go. It's further expressed by Theron in the video. He doesn't like the red pen, so he throws it out and picks up his black pen. And now we are to solve for the molecular formula. In solving the molecular formula, you first need to have the empirical formula, which we already have. It is CCl3. And we add the weights of the following atoms, and we need to use the subscripts that we just got from the empirical formula. And as per usual, my first solve will be carbon, because it is easy. I just have to multiply 12.011 by 1 based on the empirical formula. We shall do the same thing with chlorine. So it is 35.453 multiplied by 3, which equates to 106.359. And you may ask, why do we have to multiply by 3? It is because we have to base for the empirical formula, which states that the chlorine has the subscript of 3. The answer is 106.359, and we have to add both of these numbers. Here I am, calculating using the calculator. 118.37. It is the total of the molecular mass of chlorine and carbon. And last but not least is to divide the molecular mass by the formula mass. And the formula mass is the mass given in the problem, which is 237 grams per mole. Now please enjoy my handwriting as I become quiet for a good 20 seconds. Thank you. Yeah, in about those 20 seconds, I came back because I forgot to explain why we divide the molecular mass by the formula mass. And here we go. We divide the molecular mass by the formula mass to get the number 2, or to get a number, in order to multiply it into our empirical formula. And the general rule is the last number should be a whole number. And if there's decimal points, there are rules that states of how many times you have to multiply it. And here I'm just showing an easier solution, where I take our molecular mass and I multiply it by 2 or 3 and we will see if it equates to 237, which it did, and here it is. So 2, we're going to multiply it to Cl3, which easily equates to C2Cl6. C2Cl6. And once again, I am to write the molecular formula words, which I will not spell out anymore. So here is my answer. Miss Mendoza, I hope you read it. If you don't, wait a minute, I will get my camera. 3, 2, 1, I got it, my lip balm fell. And here are my answers, my empirical formula and the molecular formula. And I hope you enjoyed. And here I am saying goodbye.